Once again, welcome to the Grandson Math Academy. I say once again, welcome to the Grandson Math Academy. Before we question have baby cry. Okay, calculus differentiation. Calculus is one of the most interesting topics in math. You enjoy. When I was in school, second year, Charlie, I was learning calculus more than any other listing. Okay, where's my key? Where's my key? A moment. Okay. Yeah, I think we can start. Let me make sure that the orientation is correct. Check a page you read. Okay, it's correct. So let's move. Once again, good morning to my class. New year, more further studies. So, our concept today we want to talk about is in calculus. Use on differentiation. Okay, so let's go back to our textbook. Our source material. Yes, okay, we've done this limits and no stuff already. Oh, a moment. Sorry. I've not shared my screen yet. Thanks for the reminder. Hope you can see now. So let's go to our textbook. First principles, we've done them already. These ones, I think we've done most of them. But still, let's go through. Let's go. Now, the whole idea of differentiation is that if you have a function y equals ax raised to the power n, where a is a coefficient, the brightness is too loud. So y is a coefficient, right? And n is an integer. Should we say an integer? You can say a rational number because it could be half. So n is a rational number. Rational number q, right? So it can be a fraction, it can be anything. I don't like quoting stuff from my head, but here's it. This one we have here, right? So I've been using a mnemonic or a song to say that y equals ax exponent n. The y dx differentiation, right? Old exponent multiplication. So this number right here, it comes to multiply this one, right? So the y dx differentiation, old exponent multiplication. Say after me. The y dx differentiation. The y dx differentiation, old exponent multiplication. So now this is the original exponent that is existing. It comes to multiply the coefficient here. So it becomes a n a, okay. And the y dx differentiation, it involves exponent 1 subtraction. So exponent 1 subtraction. We subtract 1 from the exponent, and x n minus 1. So this becomes the final answer. So now let's go over again. The y dx differentiation. So the y dx differentiation, old exponent multiplication, right? The y dx differentiation, it involves exponent 1 subtraction. It involves exponent 1 subtraction. Are we okay? So this is the whole idea. When you go to integration to there's another mnemonic. I'll teach you when we get there. So that differentiation is just obey the rules. The y dx differentiation, old exponent multiplication. The y dx differentiation, it involves exponent 1 subtraction. So now let's start with a constant. If you're differentiating a constant, for example, y equals 7, right? Now, the y dx basically means you are finding a change in y or more change in y with a corresponding change in x. Now, over here, because there's nothing here, the same as x raised to the power 0. You get it? No, no, it's x raised to the power, it's not 0. Anything raised to the power 0 is 1. Yes. It's x raised to the power 0. So, when you differentiate a constant, basically the old exponent multiplication, the old exponent is multiplying here. Are you okay? So 0 times 7 becomes what? 0. So it becomes 0. And it gets x raised to the power 0 minus 1. But this one has no effect on the 0 because when the 0 multiplies anything, you get what? 0. Are you okay? So differentiate a constant. When you have y equals 3, the y dx will be what? 0. If you have equals negative 100, the y dx will be what? 0. So far as there's no x element here, eh, it's not just because there's no x, y, but the x is there, but x is raised to the power 0. And remember that anything raised to the power 0 is what? 1. That's why you don't see the x. Are you okay? And even if there's x raised to the power 0, the 0 multiplies 100 and everything becomes what? 0. So whenever you differentiate a constant, you get 0. So when you differentiate a constant, you get 0. Are you okay? Okay, so after a constant, what do we have next? Let's see. Something with an exponent. Right. So let's start with some of these. We can take the odd ones out. When you differentiate, no, I don't want to take something like that. I want to take something easier before we come to the quotient function. Okay, we can still do this one because of their exponent. So y equals 2 over x cubed. If you're solving something like this, y equals this type 1, right? Now let's go to the next type. Y equals 2 over x exponent 3. Are we okay? Now, with something like this, you know that whenever you have something like this, it's indices, right? You know that in indices, when you have 1 over a, it's the same as a exponent negative 1, right? When you have 2 over a, it is not a exponent negative 2, wrong. Mm. When you have 2 over a, it becomes 2 times 1 over a, which eventually becomes 2 times a exponent negative 1. Are you getting it? Similarly, if you have 1 over a square, it becomes a raised to the power negative 2. Now, the whole idea is that we are focusing on this exponent, the exponent here. Right, over here, there's nothing here, but it is 1. Right, so immediately you change it to this index form. It's from indices. It becomes a, if you have a raised to the power 0 over a raised to the power any number, right? You know that any number raised to the power 0 is 1. The 1 over a, it can be written as this, 1 over a exponent n. So eventually, lots of indices, a exponent 0 minus 1 n gives you a exponent negative n. Are we okay? So now from this concept, we can run back and say that whenever we are dividing or whenever we are doing a quotient function like this, we can rewrite this as what? Y equals 2x exponent negative 3, because we've changed this one from 1 over x exponent 3 towards x exponent negative 3. Are we okay? Very good. Now when you write it in this form, you can differentiate easily. Y dx becomes old exponent multiplication. Do you remember? So this old exponent comes to multiply the what? The 2. So it becomes 2 times negative 3x. Then you subtract minus 1 from the old exponent, because we are doing differentiation. It was exponent 1 subtraction. So it becomes negative 3 minus 1. Then y dx becomes negative 6 x exponent negative 4. But the question was given in terms of what? A fraction. So give your response back to them in terms of a fraction. So the y dx becomes -6 all over x exponent +4. Whenever you change this one to a fraction, the negative will become positive. Are you okay? Then we're going to check the solution. You can see that yes, that's the solution. Okay, let's do another one. 1 over root x. You have um, example y equals 1 over root x. Now the root means that that element raised to the power half. Whenever you have root of a, it's the same as a raised to the power what? Half. If you have the cube root of a, becomes a raised to the power 1 over 3. Take it as if this take it as if this thing is 1. And this one is the over, right? So the 1 goes here, a will come. If you have this one comes here as 1. This one becomes your over. And if it is 2, you don't write anything. But if it's 3 or 4, you write it. So 3, 4. So if it is n, any number over here, it becomes a raised to the power 1 over the number. Are you okay? So whenever you are doing something like this and you want to break it down with differentiation, you will write it as what? X raised to the power. Let me break it down step by step. 1 over x raised to the power half. Now we want to send the exponent to the top, so it becomes x raised to the power negative half. Okay, so now we have y equals x raised to the power negative half. So dy dx becomes the negative half is an old exponent, or an original exponent, right? So it comes to multiply the coefficients here. This one comes to multiply the coefficients here. If there's no coefficient, it is 1, right? So it becomes negative half times the 1, and x exponent negative half minus 1. Because anytime we do differentiation, it's both exponent 1 subtract. When we simplify this, we get negative half x raised to the power negative. Whenever you have a fraction like this, multiply this and this, what do you get? So it becomes negative 1 minus negative 2. No, minus 2. Yeah, because this and this gives you negative 2. All over the fraction, the divisor. So eventually I get to negative 3 over 2. Right. I'm teaching you some of these techniques so that you don't have to depend on the calculator all the time. Right, so this and this is just negative 1 minus 2, which is negative 3 over 2. Now, we have to bring it back as a fraction. Mind you, this one alone is a unit on its own, or it's something on its own, this one, right? So when you rewrite it, becomes 1 over 2, or negative 1 over 2, times 1 over what? X negative. It's not going to be negative again, it's going to be positive, because we are bringing it down. So 3 over 2, which eventually becomes negative 1 all over 2 x exponent 3 over 2. But I told you that whenever you are dealing with the set, mm, this part alone is a set. Are we okay? Let me zoom this part for you. Let me write it later. It comes to negative 1 over 2 x exponent what? 3 over 2. Now in this 3 over 2, the thing we know is that the over 2 is the set. This part is the set. So we can actually move it down. Let me drag this one and drag it here. So that becomes your set. right? It becomes your third. Mind you, these two will vanish, right? So if you have maybe x raised to the power 3 over 4, it becomes the fourth root of x raised to the power what? 3. Are you okay? You have x raised to the power 7 over 9. It becomes the ninth root of x raised to the power what? 7. Are you okay? So your algebra in calculus, your algebra should be very sharp. I do it from tiny. So now all that I'm saying is that this comes down -1 all over 2x exponent. Or let me bring the square root first. The square root of x exponent was 3. And this becomes the answer. So over here in calculus, you're applying all your pre-calculus elements. All the things you learn in algebra are bringing it. So you see that's the answer. So the cube can be inside or it can be outside, but I prefer it being outside. Prefer it being outside at the top. So you can screenshot this one. Instead of sending the PDF, then I forget. Very good. So let me see if we can do more examples. Okay, let's see the fifth one. That is quite difficult. 1 over the cube root of x exponent 4. 1 over the cube root of x exponent 4. One equals 1 the cube root of x exponent 4. This cube root, you have to write it small. Now I need to convert it. Differentiation. Now divide the x. You can. It will be difficult to do the divide the x at instant. So let's rewrite this. It becomes x exponent 4 over 3, but with a negative, because we are sending it back. Are we okay? Let me put the x here. This one alone is the third. You get it? So the over 3 is the third. So now let's differentiate it. When I'm differentiating this one, this exponent comes in front to multiply the coefficient. In our case, we don't have any coefficient there. No, we have 1 as a coefficient. So it becomes -4 over 3 x raised to the power -4 over 3 minus 1. And as I said, 3 times 1 is negative. So -4 minus 3 becomes -7. So -4 over 3 x raised to the power -7 over 3. Are you okay? Now, we want to bring it back as a fraction. It becomes -4 at the top. Then all this come down. All the x elements, because of the negative, it becomes 3 x raised to the power 7 over 3. There's a lot of algebra work here, so your algebra should be very fast. Are we okay? Now, this one, you will change the exponent 1 over 3 to be a third. So it becomes -4 over 3, the cube root of x exponent 7. You can put the 7 inside or outside. Are we okay? I'm just going to check the solution. I always want to be guided so that I won't be making mistakes. Even if I make mistake, you see, that's the answer. Negative. Let me make sure that the negative 5 is there. Yeah, so negative. Hope it's understood. Okay, so this is normal differentiation. Let's see if you can do some elements, sum or difference. This one is very easy. The sum or difference. You just do them as they are. Okay, let's see number four. Number four is quite plain, lengthy. 4x cubed minus 3x squared plus 5x squared. 4x cubed. 4x cubed. Plus, I've really forgotten what I just said. Minus 3x squared plus 5x squared minus 3x squared minus 3x squared minus 3x squared plus 5 over x cubed. So I'm going to check x squared. Okay, so I would like you to do this one. What do you do first? 5 over x squared minus 5 over 2 squared. So what do I write? 20. Alright, that's a good response. Write it well. Now, now let's do the differentiation. Take them term after term. Term after term. So what's the rule of differentiation? The y the x differentiation. Continue the song. If you wake up every day, sing the song before you go to the y the x differentiation. Old exponent multiplication. It involves exponent one sub. Say it 5 times before we do it. Clap, 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 clap on the rhythm. The y the x differentiation. Mhm. Atasa, oh bro, you have to be a rapper. Charlie, follow the rhythm and the sequence of the song. You understand? Pam, 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 pam. The y the x differentiation, old exponent multiplication. The y the x differentiation, it involves exponent one subtraction. The y the x differentiation, old exponent multiplication. The y the x differentiation, it involves exponent one subtraction. If you be an MC, Bab, Charlie, let's lucky. So 4 times 3 becomes 12x. Then you subtract 1 from the exponent. 3 times 2 becomes 6x. Subtract 1 from the exponent. This becomes negative 10x, negative 3. So subtracting 1 from the exponent. I said you do that thing yourself. I've done it for you. Okay. So let's see if we can get another one. Okay, let's do number 5 and move to something else. Half x squared minus half x squared. Okay, this 1 over 2x all squared. So y equals half x squared. Is it minus or plus? I'm going to check. Minus 1 over 2 with the x squared. Yes, do this one. Or you change. If you want to change, start changing them. So you tell him right. You can't change from indices. I, I can't. For the first one, if you like, don't change it, but change the second one. The first one, you can see that this is a numerator, and this one is a numerator. So this and this multiplies, you get x squared over 2 and minus. Mm, what are you saying? You're lying. It's not correct. You know why it's not correct? There are two different elements written over here. Let me explain to you. They may be similar, but they're not the same. This is half times x squared, which basically also means x squared over x squared over 1, right? Now this one too is half times, let me bring bracket, 1 over x squared. So you see the similarities here. This one is x squared over 1. This one is 1 over x squared. So this one, the top can multiply x squared over 2. And this one too, the down multiplies the same thing, but you want to work on the x element. It becomes half x raised to the power negative 2. So this is the correct expression. Or better still, you can write this one as half. Let your focus be on the x. Always have in mind that it can be factorized. So rewrite it again. Let me see. What do I write? It's okay. X4 is okay over 1. Minus. Okay. So what else? Still y or dy dx. Okay. So now you are ready to do the dy dx. Okay, so now what will be the dy dx? Same idea. Yeah. What about the exponent? You subtract 1 from the exponent. Okay, very. Okay, you can choose to write or you can leave it as it is. That's good. Okay. Are you sure? When you subtract 1 from here, are you getting minus 1? Hmm. Okay. So that's it. So the idea is that this number here, this one, is multiplying the coefficients here. But the coefficient here is 1 over 2. So this 2 cancels this 2 eventually. The same thing happens here. It comes here. But because of the negative, it becomes positive. Right? Then the 2 cancels the 2. This 2 cancels the 2. So I hope you're getting it now. So in the long run, it becomes dy dx cos x plus x squared negative 3. You can send a negative 3 to downwards to become 1 over x cubed. Okay, let's see. That's solution number 5. Yes, and that's what we had over here. So kudos to you. If you can do another rule. Oh, okay, the product rule. You are doing a product rule here. I think to write the next time. We have the sum and difference rule. We have the product rule. We have the quotient. Okay. They are doing some algebra. They want you to understand some algebra elements here. So let's see. Let's do these ones to enlighten our skills on the algebra. So something like x exponent. Let me do it. Let's do the second and third. 3x exponent 4 minus x. Right. So if you want to do dy dx, something you have to understand is that whenever you have a denominator, right? It's a denominator, and there are two elements or more than two elements. It means they are all having a common denominator, like 1 over 7 plus 1 over 3 over 7. It eventually becomes 1 plus 3 all over 7 because you have the same denominator. So it means you can change from this form to this form. You can separate them. Are you okay? Shabadabadamba. Shudididididididi. Okay, so this becomes 3x exponent 4 all over x exponent 3 minus x over x exponent 3. Simplify this expression as this lots of indices. When the exponents are equal and they are dividing, or when the base are equal, subtract the exponents when they are divided. So subtract 4 and 3, giving you 3x exponent what 1 minus x. 1 minus 3 is negative 2. That's 1 here. So 1 minus 3 is negative 2. So now we can do the differentiation. Dy dx becomes 3x. It will become 3x. It will become only 3 because 1 minus 1 is 0. Very good. Plus 2. Plus 2. Continue. Not minus. Say x exponent negative 3. So when you say x minus 3, when I write x minus 3, learn how to pronounce the things correctly. When you write them, so it becomes 3 plus 2 all over what? Very, very So that's it. Now let's do the next one. X exponent 5 plus square minus 2 all over x exponent 4. Hey, safely. Yes, I look out, baby. Ooh, Anka. Baby, Ningwasi. Oh, 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 oh. Ashinasia. Enemy, Kwampo. Yeah, yeah. Kapemi, oh, oh. Ooh, chuchuri, ewo. Subantin kesi mu. Nasuradia. Tuya bredi ni narasu. Ona what's nemusa. Asa kesi suni. Okay, now let's rewrite this one. What do you think the y would be? Hello? Yeah, let's rewrite this one. Okay, easier the shabre. -2. Very good, very good. My boy is learning. So now let's do the differentiation. So for our viewers who may not understand, he has actually separated all these ones. So this alone is one fraction. This alone is one fraction, and this alone is another fraction. And he has simplified all of them. My boy is good. So let's go dy dx. Hey, master, when you differentiate x, what will you get? You can get 0, you get 1. Because the 1 here, and 1 comes to multiply, you get 1. X to the power 1 minus 1. 1 plus hmm, very good. Change them to fractions. Very good, very good. Excellent, excellent response. You're improving, you're improving. I'm glad. You're welcome, you're welcome. So that's what we had over here. So from here, we come and use the quotient rule. Or what. Okay. It says in this expression, find the v in the u. It's not all the time that you get dy dx. So in this case, 2u cube minus u square. 2u cube. Missy Matthias is Charlie. Uh, take screenshots. You like screenshots. Do you learn after the screenshots? You like what? So you have a notebook that you write everything. And that's impressive. Yes, yes, yes. And I show it to your mother that Mama, me see and yes, a book now. I'll be giving her feedback of your progress. That she knows that you are improving. Now, how do you see yourself? Do you see yourself improving? Are you sure? Next week I'll give you a mock answer. You see, in our timetable, we'll be answering mock like objectives and this stuff. So that's on which time come. We on Fridays. Later in the day. The timetable, if you follow the timetable I've given to you and every day, you see that every day you'll be learning. You will know. Mm, that's what they like Jan Feb, January, February. Okay. Don't worry, when you get it, everything will flow. I'm sure the day the next time will come, the next thing will come. U cube minus u square. 2u cube minus u square. Then equals 2u cube minus 2 square. Hey, minus what? Minus u square over 3u over 3u. Now, they want to find dividend the x. Find dividend dividend the u. Be careful for you write dividend and the u. So in this case, you write solution, you write the question back again. You can split it. So start rewriting the listing. So what do I write? Step by step, do it step by step. Not step. You okay. Three you so very good. You are doing well. Today you're on fire. Heat. Okay, what do we do again? Yes, defend the you. Yes, defend the you. Very over three. You good. Very good, very good, very, very good. This is impressive. That's the final answer. Yeah, that's it. Over three you minus 1 over 3. Okay. Ooh. Let's see these two. Now in this one, you multiply this 1 over 3. 1 over x is going to multiply everything. Now when it multiplies everything, you're going to get 3 over x, 4, then 5x. And you simplify. So that's what they've done is. The next one, you separate them. you rewrite them 2 over x plus x over this. This one you can rewrite it as 2x exponent negative 1, right? What should do this one? Should do this one 2 over x plus 1 over x. So the y dx becomes what? Or you rewrite it first. Okay, rewrite. Are you there? Okay, so let's rewrite it first. So y becomes what? No, 2x exponent negative 1. Okay. No, exponent negative half. Yeah, bro, for the evidence, wow. That's negative 2. Very good. No, it's a negative. Like calculator, calculator. Negative 3 over 2. Okay, so we'll write it again. Very good. Very good. Half over biome. Okay, say what you're saying. Half over. No, we don't write it this way. This is what we've written is not ideal. Huh? This is what you have to do. Everything here is coming down to where the 2 is. It's coming to multiply the 2. So that's how it should be. So 1 over 2 x raised to the power 3 over. Then eventually the 3 over 2 becomes root of square root of what? 3. Square root of x exponent 3. So negative 2 over x squared minus 1 over 2 root x cube. Okay, it's enough for today. I think it's enough for today. Also, have to some elements. But you can try practicing some questions up to 5:30 and see. My neck is paining me. I've missing it as okay. So I don't know if later in the day we continue. Yes, yes, yes. Later in the day when it's 11 o'clock or something, we can continue. I want to at least do 2 classes a day, like 2 sessions a day. Then the other 4 sessions to continue. So 11 o'clock. Remind me at 10 so that I'll arrange myself properly. But for you, solve some more questions in the Aquila. So we've done uh, Which one? So I thought we've done the rules of differentiation. We started with the assignment, difference function. So the next thing we'll do is will be product function, quotient rule, chain rule, composite function, a function in a function. I'm sure we've done it before when we were in school, but it's good we do a recap. So, repetition is the mother of retention. Then, so 11 o'clock, we'll do the vectors. The vectors to where are we? We had that triangle problem. I've remembered how I solved it. Since I made a mistake in the solution, I said triangle problem, parallelogram problem. Where this and this. You saw the mistake I made. Since I sent it to you, here was 229 instead of 299. And here was 15 and here was 12 also. And the theta is here, in the K. So because of this value that I had wrong, I was having issues. So when we meet at 11, we'll do it. As he said, whenever I'm tired, I do the. Okay, so you take care and enjoy the rest of the morning. Okay.